This series is about all the stuff we just can't live without, whether it's products for personal hygiene, home cleaning, or even DIY. It's about those bottles, cans, sprays, jars and tubes crammed into our cupboards, drawers, handbags, sheds and cars. I want to know what's in all this stuff.
I'm Jane Moore, and I'm on a journey to the limits of scientific knowledge.
It's quite unpleasant.
And sometimes to the edge of reason. I'm chucking away the packaging to find out what's doing the really clever science inside those bottles and canisters we really can't do without. Yes, I'm on a mission to find the Wonderstuffs in our daily essentials that make them so, well, essential. And it's promising to be quite a trip.
How effective. Welcome to the extraordinary hidden world of Wonderstuff.
This particular journey promises to deliver some really crucial insights as I bust open the stuff we rely on when it comes to waging domestic germ warfare.
So that's pretty badly contaminated.
That's off the scale. I'm putting 3 of our most trusted household essentials to the test. Toilet cleaners, antibacterial sprays, and air fresheners, as we seek out the really clever Wonderstuffs, saving us on a daily basis from the worst kinds of household muck.
Later, my masterful materials guru, Mark Miodownik, reckons he can demonstrate just how bleach kills bacteria.
Boing, boing.
Oh, go on.
And explain precisely how our noses detect a bad pong.
I don't have to smell it. I can sit. Oh, look at that. It's all damp and scuzzy.
But first, I'm going to start with the grubbiest job of all.
I'd love to know, are all loo cleaners created equal? I'd also love to know what's actually in this stuff that's doing the dirty work.
Since moving our toilets inside our homes 100-odd years ago, preventing them from becoming a breeding ground for harmful bugs has been the most crucial of cleaning jobs. And until someone invents a self-cleaning loo, we have to rely on chemistry. So to find out what's in Loo Cleaner, I'm off to the headquarters of J's, who make an awful lot of the stuff. Technical Director Dr. Max Gowland is going to unpack the science that goes into the bendy bottle, starting here in their rather unique testing facility.
Well, welcome to J's, Jane. Flushing Meadows. This is where we do all our toilet testing.
How many toilets have you got in here?
We have about 250 toilet bowls plus cisterns, so it's a huge test facility. I would guess it's easily the biggest and most impressive facility in the world.
This is the most bizarre room I think I've ever been into in my life.
We have a computer here which controls the flushing.
Right.
And obviously we have to test maybe 5 flushes a day, 20 flushes a day, 90 flushes a day.
I was going to say, 5 flushes a day wouldn't serve my house.
Absolutely.
I'll tell you, not with all my kids.
Oh, well, here we go. We're just in a flush cycle now.
It's like a loo symphony.
Yeah.
And if I thought the 200 loos in Flushing Meadows was odd, Max assures me I ain't seen nothing yet. Their smelling station allows the team to test the likability and staying power of the smells they add to loo cleaners.
Blimey, this is very 2001 Space Odyssey. So how many fragrances are you testing in here today?
Currently we're testing 3 or 4 fragrances.
So if I open one of these doors, I'll be able to test a smell?
Yeah, absolutely.
All right, well, don't tell me
By
what
all
it
means.
is. I want
Okay.
to see whether the old bugle's working. Here we go. Oh, there's a loo in here. I was expecting it just to be a fragrance booth. That's lemony to me, I think.
That's not bad.
Yeah, that smells sort of lemon.
Not bad. Yeah.
And then you put some sort of poncy word on the end, don't you? Like
fruity.
lemon breeze or
Yes,
something.
yes. It is a fruity smell, so
Is it? What is
very
it?
well. I'm not really sure what the exact name
Let's
is.
ask the people who know.
Okay.
What's this one here in here?
Fruity punch.
Fruity Punch.
There you go. How's that for a name?
That wasn't too bad, was it? Yay! I'm going to come and work here.
And next, the hot room. Sounds promising.
37 degrees centigrade, which is pretty warm, but it's also 75% controlled humidity.
Oh, lovely. Yeah, come on. Let's give it a go. Don't lock me in there.
Who knew that keeping the loo clean required such appliance of science?
Very hot and very humid, because we need to make sure that our products are stable to various conditions like warmth and also humidity, especially if we're selling products overseas. So,
See, look, 20 seconds with me and a man's glasses steam up.
I'm enjoying my tour of the toilet cleaning house of fun, but time to get down to business. Max has laid out for me the full array of different ingredients they work with when concocting their products.
here we are. Well, there's quite a few ingredients.
Apparently there are 15 or so different substances you can cram into the bottle. Colour, so you know where you're putting it. A foaming agent and a detergent. Thickener to help the liquid cling to your toilet bowl. And something to help prevent calcium carbonate buildup, or limescale. But there's one ingredient I really didn't expect. Flavouring?
This is called denatonium benzoate, and this is a material which allegedly is the bitterest substance known to mankind. And all you need are a few parts per million of this in your product, and nobody will want to touch it.
So that's if little Johnny or Jemima come along and might get some of that, it would put them off eating it.
Yes. Would you like to try some?
No, thank you very much.
OK, I get the point. Your more complex toilet cleaner is multitasking, but none of the ingredients so far would stop a superbug in its tracks. So where's the Wonderstuff I'm looking for?
Well, the real killer for germs, there's only one real mega material, and that, of course, is chlorine bleach, or otherwise known as sodium hypochlorite.
Despite the complex formulation, our Wonderstuff is actually good old bleach.
Bleach is a fantastic chemical. It's highly efficacious, it foams, it cleans superbly, it kills every bug stone dead, and also it's absolutely perfectly safe for ceramic. So, fantastic ingredient.
But Max has a bit of a surprise for me about exactly where bleach comes from.
Bleach basically starts its life as common salt, or brine, salt in water. So the brine is turned into, using an electrochemical process, into sodium hypochlorite bleach.
So bleach comes from salt water.
It does.
Who'd have thought it?
But what makes bleach so good at killing germs? Luckily, I have my handy materials scientist, Dr. Mark Miodownik, on speed dial to rustle up an answer.
Hi, Mark.
Hi, Jane.
How are you?
Yeah, I'm fine, thanks.
So obviously we're here with this fantastic view and right by the Thames. Now I'm guessing because we're talking about bleach, you've brought me here because this used to be one gigantic sewer, didn't it?
Yeah, I mean, it used to be, obviously responsible for a lot of ill health and the big stink of London, and now we've built enormous pipes to funnel off this sewage, and we've got bleach, which is dealing with a lot of the problems.
That's all well and good, but I'm hoping Mark can prove to me that bleach is actually killing the invisible bacteria in my loo. He has a handy bottle of E. coli bacteria solution in his pocket, like you do. Apparently the cloudiness is down to the live bacteria in there. Add bleach to it, however, and the liquid becomes clear, meaning the bacteria have been zapped. Bleach's killing power is obvious, but what's it actually doing to the bacteria? Cue half a dozen props. Mark reckons these raw eggs, with their shells removed, are a bit like giant E. coli bacteria. Any bleach coming into contact with them goes on a two-pronged attack.
These things actually will you'll get holes poked in them. So the sodium hypochlorite from the bleach is punching holes in the membrane of the bacteria. And of course, as you can see, that means that the insides of it start spilling out. That's called cell lysing, and that spells death for the bacteria. So what will happen is essentially things like this will happen. Boing, boing. It's not feeling very well now.
I'm not surprised. Hello, I used to be an egg.
Getting what looks like cooking.
As well as
going.
bursting open the bacteria, the bleach will also chemically cook the protein inside them, which of course spells death to the bacteria. So if bleach is so deadly to living cells, how come it's considered safe enough to flush down our loos and be let loose into our waterways?
What happens after it's gone down the loo? What sort of reactions are you talking about?
It turns out that it's so reactive, so this bleach, that it reacts with almost anything. So as it's on its way down your sink, down the drain, it's reacting away, and almost all of it's reacted away into quite benign products like salt and water.
So pretty much how it started?
Yeah.
Apparently, the received wisdom is that bleach is one chemical you can flush away without feeling guilty. This leaves me in no doubt that sodium hypochlorite definitely qualifies as a bug-busting wonderstuff. It's the bleach that has given us reliable germ killing for decades, and in the war against bacteria, it's still hard to beat.
But what about cleaning those surfaces you might literally want to eat from? After all, if we can't actually see the germs that certain products claim to get rid of, then how do we actually know they're doing their job? I reckon it's time to find out whether something in antibacterial spray is going to make it into our Wonderstuff Hall of Fame.
I suppose it's since I've had kids and sort of pets around the place, I've become more conscious of germs and whatever. But when I look at this, it says it kills 99.9% of bacteria and virus. So I think, well, that's good. But then I read it says you can use it on changing mats, playpens, high chairs. So I then start to think, well, if you can use it around kids and on the things that they use, is it actually strong enough to do what it says on the bottle? To help find out if there's a different kind of Wonderstuff making antibacterial spray live up to its boasts, I'm bringing in a professional microbiologist.
You come in.
Dr. Ron Cutler is Deputy Biomedical Director at Queen Mary University of London, and he doesn't mess around. I'm told to make myself scarce.
I'd say it's rather weird taking my dog out for a walk knowing there's a bloke in my house swabbing it for bugs. Ugh.
A couple of days ago, Ron asked me to prepare for an experiment that will demonstrate how effective an antibacterial agent can be in areas where we prepare food. He got me to cut up some raw chicken on a wooden chopping board and not clean the board afterwards. Now comes a techie gadget. This looks like something they might have used in Ghostbusters, but apparently it detects a substance called ATP that's present in all organic matter, like on my contaminated chopping board.
So we'll just take the bacterial swab and we'll just go over an area here where it looks as if it's very, very dirty.
I suspect it might be.
And then what we'll do is we put it back into its tube, close it, and we just put the tube straight into here.
God, it's clever, isn't it?
And we close it, and we press the little on button. OK. And wow, it is really contaminated.
So what, right, hang on, to my layman's eye, what does 193 do? Right. That could mean...
If you look into this little bit here, it tells you what the high and the low is.
Yeah, 30 high, 10 low.
Yeah, and you've got 193. So that's pretty badly contaminated.
That's off the scale?
Off the scale, exactly.
Wow.
But what difference will a quick wipe down with water make? Well, the answer's not much.
That's like a difference of 1. That's nothing. So it's not really, it's just wipe the germs around a bit,
Absolutely.
really.
Will my family-friendly antibacterial spray be more effective?
Spray away.
Get a bit of a pump going there.
So just do as you would normally do with your cleaner.
Yeah.
And let's see if it's an effective method or not. And one of the secrets of these things, of course, is it smells effective.
Yeah, it does. I'm feeling reassured already by the smell of disinfectant.
Disinfectant, yes.
OK, right. Oh, I get to put that in as well now,
Close the lid.
Press OK.
Press OK.
Right, bets. What do you reckon?
60 to 70.
61. You've done this before. You cheated.
Given the board had been left to fester for 2 full days, that's a big difference. There's clearly something in my antibacterial spray that's working.
Oh, that has really worked, hasn't it?
But it still hasn't done a full clean-up. Ron puts this down to not leaving the spray on long enough to be fully effective.
Because the material is actually almost ingrained onto this board, it's actually very, very difficult to remove stuff like this. Really, there's no excuse. You must clean the area and make sure that you get rid of the dirt and allow the antibacterial agent to actually destroy the bacterium that's there.
Ron's determined to show me that my antibacterial spray can kill a lot more germs if left to work long enough. So he's taking me back to his lab to prove it. But before he reveals the magic substance in there doing the bug-killing work, I want Ron to put my mind at ease. Will the rest of my house prove to be as fetid as my chopping board? One look at my samples and my heart begins to sink. The Petri dishes of shame. But Ron's actually got some good news.
Well, there's nothing at all dangerous in any of these organisms here. Basically, what they are is completely safe microorganisms that live in the environment.
Apparently, many of the benign kinds of bacteria kicking around our houses actually help keep our immune systems primed for action should something more nasty come along. But that's not the case with my chopping board. Ron shows me exactly what's been growing there, and it's pretty bad. Uh-oh.
This is what we actually managed to isolate. This is an organism called Escherichia coli.
As in E. coli?
As in E. coli. There's a whole range of variations of E. coli, and chicken just happens to be one of the sources of these, especially raw chicken.
And remember, that's even after I'd cleaned it. But Ron insists there is a killer ingredient in antibacterial spray called benzalkonium chloride, and he's got a neat little trick up his sleeve that he thinks will prove it. He's put a single drop of benzalkonium chloride into the middle of an E. coli colony. After a few hours, something really amazing happens. A clear circle has appeared in the centre of the Petri dish, and compared to an untreated colony, the bacterial devastation is obvious.
You can actually see that there's a fantastic difference. So this is very effective at killing bacteria.
I'm impressed. The evidence speaks for itself. This benzalkonium chloride in my antibacterial spray has proven itself against the might of E. coli. If you leave it to do its job, it's a really effective chemical to have around the house. It offers the bug killing of bleach without the unwanted taste and smell. You'll also find it in mould remover, and it's even safe enough to use in eye drops and nasal sprays.
Onto a different kind of invisible dirt, but one that's certainly harder to ignore. Nasty odours. It's a problem that calls for a solution to be conjured literally from thin air.
Your home might look like something from a style magazine, but throw in some bad odours and you're sure to make a lasting impression, for all the wrong reasons. Like most, I think smelling clean means clean, and I do use air fresheners. But am I actually getting rid of the problem, or just temporarily covering it up? Time to get some answers from one scientist who always comes up smelling of roses. Mark reckons he can show me how bad smells get right up my nose.
Who is that? I can smell someone. Hello, Jane.
Hello. Now, you know, you told me to bring something really smelly. This is my dog Jasper's bed.
Oh, that is dog smell.
Yeah, it's damp,
Yes.
been in the pond dog smell.
You probably quite like that. It's probably kind of emotional attachment.
No, I don't like it at
okay,
all. I'd
all
like
right.
to get rid of it, frankly.
Well, I've got a nice smell for you.
Oh, go on.
In contrast, this is my trainer.
I don't have to smell it. I can sit. Oh, look at that. It's all damp and scuzzy.
It's actually remarkably. You get used to it after a while.
Actually, I'm actually going to retch.
So what's happening when we smell something as rank as Mark's trainer?
A smell is a direct interaction from, let's say, this cheese, for instance. So what you're smelling is a molecule. I'm going to represent this little light as a molecule coming off this cheese, and it's bouncing around the air. Sooner or later, one of them is going to get near your nose, and it goes up your nose, and it hits the mucus in your nose, and it actually is absorbed into the mucus. So a bit of cheese is in your nose now, and that's what you're smelling. It's actually a physical thing that you're getting in your. So when
if you smell dog poo, you've got a bit of dog poo in your nose.
Yes. That is amazing.
Now
it's
not amazing, it's rather hideous actually, if I'm honest.
Yes. And then there are these receptors in the mucus which are picking up what's in there, and that goes to your brain. Your brain says, hey, I smell dog poo.
For centuries, we apparently relied on just covering up horrendous whiffs with nice-smelling stuff, like flowers.
There you are, look at that, lovely.
Great, I'll put those back on again.
That's worked.
That's actually,
It has, hasn't it?
Yeah.
But to my mind, for something in air freshener to qualify as a Wonderstuff, it's got to actually kill smells, not just mask them. And many of your fancy odour eliminators claim to do just that.
It all kicked off in the 1950s. People start to realise that not only can you just put nice smells into the air, you can actually identify bad smells that are in the air and break them up before they hit your nose. So sort of grab them and kind of change their chemical nature. And these are called deodorizers.
Deodorizers that attack and destroy smells in mid-air? Sounds like clever advertising to me. To get to the bottom of this, I'm going to have to speak to some real smell super boffins. This is the rather fragrant global HQ of CPL Aromas. They're responsible for creating some of the very latest high-tech ingredients in our deodorizers.
Now that's what I call a house. I do hope Jeeves has got my gin and tonic ready.
My Jeeves turns out to be Global Head of Research Tim Whiteley. According to Tim, we all have unique smell receptors in our noses, like a fingerprint, and he's going to test how good mine are.
Quite nervous.
I'm feeling the pressure now, Tim. I think I've got a pretty good sense of smell. But it turns out that when it comes to identifying a pleasing aroma, it's not as easy as you'd expect.
It's, I would say, like a lemon verbena.
The general character is actually rose.
Rose? I'm seeing sweetie jars, I'm like a, oh, blimey, like a cough sweet.
And if you like pear drops...
Pear drop, oh my God, yes.
Blimey, this is a lot harder than my toilet cleaner smell test.
Well, this one is actually lavender oil.
That's what it is, lavender. How could I not get lavender? I think that's peppermint. That's spear.
Very good. First two are spearmint.
Yes!
The last one's peppermint. Yeah. There you go.
So have I got a job?
There's room for improvement, but I think we could work on you, yeah.
That's a no then.
Darn it. Weirdly, recognising nice smells is much harder than identifying nasty ones, as Tim's about to prove.
Oh, I'm such a trusting soul, aren't I, hey? I can smell it already.
Here we come. Just have a smell.
Oh, God, I don't like fish at the best of times, and that's fish that's very off, isn't it?
Yes, it is.
So how can we register bad smells so much more easily than good ones?
Well, we've got two senses of smell. We have our olfactory sense, which is where we normally smell more pleasant items. But then we also have the trigeminal sense of smell, which is really our evolution, our oldest sense of smell. Materials that you smell that are likely to do you harm are the way you will smell trigeminal. It's our most direct route into the brain of any sense.
So apparently we've evolved a separate, ultra-sensitive sense of smell just for detecting strong, potentially dangerous odours. And that's what makes covering them up so difficult. Apart from just masking smells like Mark explained, Tim's deodorizers contain some high-tech aroma molecules that actually attack and destroy bad smells so that our noses can no longer smell them. It's complicated, but he's got some balls to help me understand. First up, a molecule that can make a bad smell disappear from thin air.
So, say this is our malodour. In a combination reaction, the aroma molecules come in, they combine together to give a much bigger molecule that's a lot heavier, and it's actually so heavy that it will then physically drop out of the air.
And therefore it's not in the air and we're not smelling it.
That's right.
Clever stuff. And his second cunning deodoriser molecule works directly in your nose by blocking the smell receptors.
This has enough similar shape to kind of bind to the same receptor that your bad smell would normally bind to, and so changes what you smell.
It gets to the nose, the receptors in the nose first, and sort of blocks that little bit of the jigsaw so that the bad smell can't fit in there.
Yeah, exactly.
And the finale, a molecule that tricks you into thinking a bad smell is a nice one.
You're actually changing the shape of the malodor molecule itself. That shape, in terms of how it binds to the receptor site, is different to that shape. So while that shape gives you your bad smell, that shape gives you your more pleasant smell.
And to show how effective it is, he's got one last test for my exhausted nose.
This is a material that we would class as not particularly pleasant and is found in quite a lot of malodors.
It's sort of damp dog.
My smell arch enemy, to which Tim adds a few drops of his stereochemical binder.
Give that a little shake. Okay.
Oh yes, that's much more pleasant. Yeah, it's sort of fruity.
Fruity, orangey.
Gosh, yes, no, that's much, much nicer. That is utterly astonishing.
Now,
These stereochemical binders are genuinely wondrous. They leap on our bad smells and turn them good. Over the last 50 years, researchers have developed a range of potent cocktails to attack different kinds of pong in mid-air. Much as we'd love to tell you some catchy names that you might read on ingredient labels, unfortunately, like Coke and Colonel Sanders, they're a trade secret.
On this particular Wonderstuff hunt, I've turned my home over to the microbial mafia, and I've learned that the simple brilliance of bleach just can't be beaten when it comes to killing harmful germs. But I suppose I've been most blown away to discover that bad odours are actually just airborne little bits of filth floating around. Yuck. But luckily for our nostrils, some of our best inventors have come up with some fancy chemical action that works in mid-air.
Next time, I come over all practical and dive into the extraordinary world of the substances that hold our lives together. I push sticky stuff and my nerves to breaking point in the search for the magic in glue.
It's a good job I've got a strong heart, isn't it?
I dig down to find the surprise at the core of the world's slipperiest substance.
It's like Raiders of the Lost Ark down here.
And I uncover an unexpected genius Wonderstuff that links paint, paper and cottage cheese.
If there's any organic matter near it, it makes it disintegrate.
That sounds astonishingly clever.